So we have number 18 here. Find all solutions of the equation in the interval 0 to 2 pi. So our equation is negative 4 cosine x equals negative sine squared x plus 4. So what we're going to do is get everything on the left side of the equation by adding sine squared x to both sides and subtracting 4 from both sides. And that gives us sine squared x minus 4 cosine x minus 4 equals 0. Now what we're going to do is use the fact that the Pythagorean identity sine squared theta plus cosine squared theta equals 1, and if we solve that equation for sine squared theta, we get 1 minus cosine squared theta over here. This is something you should have memorized. So we're going to substitute in 1 minus cosine squared theta in for this sine squared x. X and theta are the same, it doesn't matter. And that gives us 1 minus cosine squared theta that replaced this, minus 4 cosine x minus 4. And then we consolidate the 1 and the negative 4 into negative 3. And we have negative cosine squared theta. That should be x, sorry. Minus 4 cosine x minus 3 equals 0. I don't like negatives, so we're going to multiply all the way through by negative 1. Now give us cosine squared x plus 4 cosine x plus 3 equals 0. Now, just like in the last problem 17, this is in the form, you can put it in the form of a quadratic equation. So we're going to say that t equals cosine x. And we're going to sub in t for cosine x. So we're going to get t squared plus 4t plus 3 equals 0. Alright, so then we factor that like we did in Algebra 1, Algebra 2. We need two numbers that multiply to be 3 and sum to be 4. So the two numbers that multiply to be 3 are 3 and 1, and it'll be a positive 3 and a positive 1, because positive 3 and positive 1 is positive 3, and then you sum these two, it'll be a positive 4. So the next step is to sub back in cosine x for t. And then what we're going to do is set each of these, this equal to 0, and then this equal to 0 independently. So first we're going to focus on cosine x plus 3 equals 0. Subtract 3 from both sides, you get cosine x equals negative 3. And if we go to our special triangles, right here, none of our cosines is equal to 3. And then on our unit circle that I showed on a previous problem, there's no value of 3 for cosine. So this is undefined. Well, why is it undefined? Because if you draw a right triangle, and you say this is angle x here, and then say this is understood to be over 1, cosine of x equals adjacent over hypotenuse. We can't have a negative dimension for this right triangle, so this is undefined, and it makes the whole problem undefined. And if you have any questions, let me know, please.